The mysterious mysteries of the enigmatic. Well, we'll just be debunking the Lost Ancient High Technologists on the Serapeum of Saqqara. This will be part one. It's hard to unpack this quickly, so we'll go through it point by point. But firstly, let's address what are the actual claims for ancient lost high technology. What do the Lost Ancient High Technologists actually say is evidence for this advanced advanced lost high civilization and the Saqqara Serapeum?
And the mystery only deepens when you see what the tunnels lead you to. 24 mighty, precision-carved, single-piece stone boxes and matching gigantic lids, combined weighing up to 100 tons, most of which are finished and polished so well that they are still reflecting light after millennia in the dust, all housed in sunken alcoves like the engines and generators of some vast underground machine. Of this video series, the links are below if you haven't seen them. We've examined some of the evidence that a form of ancient high technology must have been used in several aspects of these boxes' creation. Technology that cannot be attributed to the dynastic Egyptians, nor achieved via the tools that exist in the archaeological record. From the unrelenting precision and flatness of the interiors of these boxes, to the mirror-like finishing polish of the outsides, to the challenge of quarrying, shipping, and moving such massive objects into these locations, the orthodox explanation that this was all done by a primitive ancient civilization with nothing more than hand tools and human power reveals itself as simply logically unsupportable. Therefore, a new theory is needed.
Basically, the standard argument: it cannot be done with dynastic era tools. The precision requires advanced machinery. Therefore, since it cannot be done with primitive ancient tools and it's a clear indication of machinery, therefore these items are evidence of advanced lost civilization. This episode will be focusing on really one point, and we'll look at the weight as well. But could these boxes have been moved inside the Serapeum?
Pyramid is the Serapeum. Here there are 20 huge granite boxes, each weighing 100 tons. Classic Egyptologists say these are coffins. Yet, the granite here came from 500 miles away, and each box is so large and so heavy that there's no possible way it could fit through the existing tunnels and entrances.
The fact that these boxes are located within their own little nooks, and one of these nooks where the box is found in, based on the dimensions of the box, and we're talking 15 feet long, 10 feet tall, absolutely huge, could not have fit around the corner of one of these tunnels and into the...
Before addressing the other claims, such as its machine precision, carved and miraculous, impossible polish, and that it's impossible to make those boxes, and that's what essentially they are, boxes with primitive dynastic tools. So the first question we'll address, and it takes a long time to unpack this nonsense, I can just drop it down as a fact, but to unpack it you have to go through it point by point and look at it. So is it impossible to get the coffers and lids inside? They do not fit, implying even with modern technology you could not do these things. And also, we'll touch on the question, do they weigh up to 100 tons including the lids? So before I begin, I'd just like to thank Sherif kadi. He did a great video, just basically a single shot tour, walking through the door all throughout the Serapeum, the major gallery, and then back towards the entrance. So that video link will be in the description, and most of the other media come from the Azita project, who have an excellent catalogue of photographs. Okay, so the stones are too large to get inside the Serapeum, therefore advanced ancient lost high technology. No, you can fit the stones through the entrance and place them in all of their final niches. So here's an image of the entrance. We come down a staircase towards this front door, and well, this is all modern masonry. Exact date I'm not sure, but this was added after. Okay, now we have an inside view of that same door, and again you can see where this masonry wall has been added. At some point it just wasn't an issue, and there's a ramp entrance down into the Serapeum, and it's a ramp. Gravity is going to help you, and there we have more modern stairs. But before the masonry was put into place, There was more than enough room to get the blocks inside. For instance, there we're seeing 2.2 metres wide. The block, now there is one 2.5 metres. The box, the coffer in niche 2, that's 2.5 metres. But so we take this image, and how do we know? Well, we see that guy there, and how high is he? Well, let's assume he's short. Let's say he's 5 feet, 1.52 metres. Copy 2 of him, paste him sideways, and what we have is 3 metres or 9.8 feet wide. So we need 2.5 metres and a little bit extra on either side. We have 3 metres being conservative. So we can get that on the inside. So 2.2 metres, that's the box in niche 17, probably the heaviest. But also here's the largest one. It's in niche 2, it's 2.5 metres. So we have the room to get inside, and the narrow gap on each side will actually assist us later in getting it through the door and turning it around the corner. So keep that in mind, that the walls being this narrow is not a hindrance, it's actually a helpful factor. All right. So now we're inside, and there we can see the entrance door. We're looking, that's lid number 1 or object number 1 there in the centre, and off in the distance is niche number 4. You can see one of the coffers there. But again, we can use that gauge, and so we're assuming he's short, he's 5 feet. Stand him on his head, so we get a good idea. We're looking at about 9 feet to the top of the door. So we can, from the bottom to the top of the door, so we can use that as a gauge. Turn that sideways, stretch it out, and we're looking at about 4.38 metres. I'm just working off those numbers. So again, margin of error, and I'm being conservative. So we have 4.38 metres from the wall to the door itself. Of course, there's room on the other side of the door, so that's 3.8 metres long. That's the same as niche number 2. That's about the Mac. Now, even if we want to make them a little bit longer, we still have that room. But so these stairs and floor, they also raise the original ground level. So take those away, you could make an earthen ramp or etc. there. But this is a tight fit if you brought it in dead straight. But you would not bring it in dead straight. You would begin to turn before it was fully inside. And this is where the narrowness of the entrance passageway to the size of the blocks will come in helpful. But again, you don't go in straight. Just like moving furniture, you hook chairs around the doors, and not only do you slide these things in. You don't have guys holding them up and struggling in, as is the imagery shown. The comparisons shown by the Lost High Technology channels. They always, it's almost like an infomercial. They'll get the clumsiest, most incompetent people who can't do anything and go, well, look, they can't do it. But anyway, this is, if you've ever moved anything, you should sort of have this, even without someone teaching you, you don't need a PhD to learn this. These are the types of things you should just pick up in your, childhood and early adulthood. So you don't bring it in straight, you begin to turn earlier. So begin the turn before you're fully inside and there's more than enough room. All right, now notice that there is also these cutouts in the wall. Now, especially the one on the left there would be very helpful as well to bring it in. So that because that's next to that masonry wall. These cutouts would be helpful. So we take, there's the map view. We can see the entrance there on the right. We're coming down. All right, so once you've got it in the door, now for instance, niche 4 is just straight from that point. But how do you actually get it in? How do you turn it? Well, you need advanced precision bearings to do this. This is impossible. Well, no. Now here we have some examples from Egypt and Sumer where they use socket and ball, essentially a socket and ball joint for heavy temple doors, and also at the Bent Pyramid where you can see multiple limestone pivots have been worn out. So, and it's in the record, but I'd also point to Wally Wallington. This is one of the videos that have been posted on him, building Stonehenge, a man who can move anything. He moves big heavy stones. He even moved a barn, and all he did was put a pebble, a pivot underneath. and then gravity will assist you. Now, he doesn't even use in this move compound pulleys. He just uses leverage and pivots. And great quote where he says, he uses gravity as a tool to his advantage rather than look for an excuse. It must be Lost High Technology. There's a bit of a typo, but I don't think that this would be the best way to do it. Not in a tight spot, because if you brought it in straight, and you'd also have the issue of getting the...
I found a simple explanation for this, to move a block about the weight of a minivan, would be to place a stone underneath it. And once I balance on it, I can spin it. Of course, with that spin, you've seen I didn't go anywhere. But I got two handles on my lever, and I could place another stone on this side. Now, every time I spin a half rotation on each stone, I move the block horizontally, the distance between the stones. With my own output, I could move a 1-ton block 300 feet per hour.
Using this technique, he's moved everything from 1-ton blocks to buildings.
He moved up to a pole barn at one point, a 30 by 40 pole barn that he moved 300 feet for me, and it was more or less, what else can we move? And he looked at me and says, hey, can we move your barn? And I said, sure, let's, next thing you know, it was 300 feet in the other direction onto another piece of property.
It can move barns, and while he's betting, it moves...
Pivot in under there. So, one possible, but I don't think it's the example. Now, I think it'd be better to look at an example like this, where they're moving these big heavy blocks on a sled, which is on top of rollers. Similar images to this, where people, back in the day, before cranes and advanced technology, were moving giant blocks. You can even see that block would be heavier than the heaviest object in the Serapeum because it's a solid block. The heaviest coffers, the boxes there, are hollow. So, and even by scaling that block to the gentleman standing there off on the side, you see how large that block is. But when they came from the quarry, it's not they didn't have a dead straight expressway from the quarry to where they were delivering it miles and miles away. They had to pass down. You can see hills in the background, mountain roads, which include switchbacks and all sorts of turns going up and down. So you can align your rollers to go around corners. This is not a difficult thing to do. I couldn't find, but obviously they're coming down these mountain roads. Now I'll show you another example where this 300-ton monolith on a sled with lubricated rails was brought down, turned around a sharp corner, and then just like getting some thread in a needle, they had to fit it through this archway to get it underneath that viaduct or the bridge that they have there. And this was done with primitive tech, with rails and sleds to bring it down, and it's a very direct, it's a great modern example, but it's also a direct comparison to just like bringing the Serapeum coffers inside. It's almost identical in that way. So primitive technology can be done, has been done, it's just not an issue, all right. Now, we looked at a record where the Egyptians actually used sledges, and we have images of them moving heavy objects, including a Colossus statue, and using the sled. There's more than just one surviving sledge, made of Lebanese red cedar as well. So this was a method that was employed, and it is in the archaeological record. So also for this part of the move, it closely resembles this, and it's much heavier stone as well. They're moving a megalith down. Here we see a 300-ton monolith being brought down, and the technique of a sled using rails to slide it down, and then it comes to a choke point here where they then have to start turning it, bring it down a steep embankment, and just like threading a needle, they're going to pass it through a very narrow arch. Essentially what you're seeing here is what needed to be done to bring the boxes inside the Serapeum, but this was across much more difficult terrain and with a much larger stone, but it's all rope and very simple technology. They're not using advanced modern technology at all in this port, and for most of a portion, what few modern contrivances such as a steel pulley could easily be replaced with a grease log. So what you're seeing here is many Serapeum coffers all at once being brought in, passed down the embankment, turned, and then passed through a very tight passageway, even tighter. There's less room here than there would have been at the Serapeum. So this is an example I'll show a little bit more later, but caught on camera, just old school knowledge, a little bit of basic physics. Not that would have been studied at university, just would have been picked up by these guys working in the quarries from their youth and then developing their skills. Again, this is not advanced. They didn't have professors and teams of scientists working this out. This is just old school sleds, rails, people who knew how to rig their ropes, how to apply their ropes, how to work hard, how to apply a little bit of logic. So this will be an example and basically the technique that was required to get the Serapeum boxes in there. And we're looking further into how they got through the corridors and then into the niches, and then how they were lowered into the niches. But more of that to come. But this will be one of the prime examples. Around and through a tight entrance. So just like the Serapeum. So we close up there on the entrance. Now notice how there's that little bottleneck. Okay, but that bottleneck, again, we showed earlier, those are masonry walls. We can remove them. So we have the passage coming straight in. And I'm marking 4.5 metres to where the door is. Now, but there's room outside of the door. So we also have that cutout. So we have a nice little, just a little bit of a corner cut out of a corner. It makes a massive difference if you're moving furniture into a tight spot, for instance, as well. All right, so we'll use the larger box as an example. The Amasis, which is in sarcophagus number 2, in niche number 2, 3.8, 2.5 metres wide. And again, it's coming down a ramp. So gravity is our friend in this case. And it's just a matter of starting to move and turn it before you're fully inside. Now, the power of levers and ancient technology. It's solid. Like, you cannot argue with it. It's confirmed. There are online calculators and very clear, excellent formulas which tell us what the mechanical advantage is from a lever. So each lever here, 2.5 metres, 5 Egyptian cubits. We get 3 tons, 3,000 kilos, 6,600 pounds, or what's called, I noticed on my conversion, 1/3 of an elephant, with only 120 kilos force. So each guy just needs to put 60 kilos force in. Would that be around 100 pounds? And he'd be getting 3 tons on each lever. So there's the elephants. I'm not sure, I've never heard of that before, just included it. So 6 guys with levers on 3 levers would be getting 9,000 kilos or 20,000 pounds of force being applied on these levers. I'll show you an example here where we were doing some experiments on how they moved the stones to Stonehenge, and what they use is levers, and it's like a rowboat technique. So they lift the stone and then they walk forward. Now, it's worth including there, because if you see the footage, will you count the people on the levers and compare it to the 13-ton stone? But of the simple machines that make up all our modern complex machines, the lever is the simplest and almost certainly the oldest of the simple machines. And again, it's worth noting they're lifting and then they're moving the stone forward, which is why the short part of the lever, that which goes from the fulcrum to the weight there, if that was shortened, that would increase the power of a lever significantly. But they're lifting and moving. But I'll include that clip in the description. I'll try to remember that. I'll do some editing later and show you these videos of, for instance, the monolith in Italy and these examples too. So this is just a demonstration of really what can be done with levers, but they're not like just pushing them sideways to adjust the turn of a Serapeum boxes, for instance. Here they're lifting these blocks and then walking forwards to move them. So it's like a rowboat technique. So it's about moving the blocks, but it's more a demonstration of levers. Now, the short part of a lever is much longer than what you would if you're just levering the Serapeum boxes. But again, just as a demonstration, levers probably the oldest of the simple machines. They're just effective. All modern technology is really levers, inclined planes, and pulleys are basically the basic components of all complex modern machines. And so, yeah, with a lever, as was Archimedes, give me a lever and a place to set it, and give me a lever long enough and a place to set it, and I shall move the earth.
How do you do, ladies and gentlemen, and boys and girls? I am Julius Sumner Miller, and physics is my business. And our very special business today is the subject of simple machines. Simple machines. Now, when you study these matters in school, it is usually said that these are the 6 simple machines. The lever, or as some pronounce it, the lever, the inclined plane, the wheel and axle, the screw, the wedge, and the pulley. And I wish in this program to show that really all of these reduce to only 2.
Before we go into the physics laboratory with Youssef, expert in Lost Ancient High Technology, I'm just going to do a little review of the basic machines and ancient technology and what never lost ancient high technology, such as the lever. Settled science is the power of the lever, and also the strength of what certain woods are. But so these are simple machines, as as they're called. All modern machines are pretty, there's maybe, basically every single modern machine we have is just a variation on these simple machines. Now, an inclined plane or a ramp. Okay, now a wedge is also essentially an inclined plane, and so is a screw. Now, for instance, a screw is just a ramp that's been wrapped around a cylinder. Now, where does the power... A ramp makes you stronger. It gives you mechanical advantage. Now, an example of that would be a jack to lift up your car. It's a screw and with a scissor, but it's all you have there is a ramp wrapped around a cylinder. And so you get... anyone can lift up a car with a very simple device. These are simple machines, and these are how they still work in modern times. So a ramp, I should have included a wedge is essentially an inclined plane. It works pretty much the same way. Okay, now wheel and axle. Well, wheel and axle is more like a gearing system. I'll show you that in a moment. But wheels or rollers, again, are ancient machines. Earliest dynastic Egyptians had wheels, despite what you'll hear. They didn't have wheels. They didn't have pack animals. This is just nonsense by the Lost High Technology, people. All right, so now we have levers, but a better way to think about, we don't intuitively think about it that way, but levers are gears. So there's a great video, Spinning Levers, how a transmission works. It explains how a gearbox works, and it's the title there, Spinning Levers. A lever is really just a gearing system. So if you take away if you extend the cogs out, it's just a series of levers connected to a wheel that gives us the massive mechanical advantage that comes from gears. Just you put your car in low gear, you'll power up the steepest hill, dragging the heaviest weight. Same with a push bike. Just go into low gear and you can strike your way up the hill. If you go into high gear, then you're not going to go up a hill. Another example of a spinning lever or a gearing system would be just a good old-fashioned well winch. The drum where the rope wraps around has a smaller diameter than where the handle is, so it's a gearing system. It gives you a mechanical advantage. These things are ancient and they're everywhere, and we just don't really appreciate them enough. A capstan, as they're called on sailing ships, is the same principle. You walk around a big circle, turning a small drum there in the middle. It's a gearing system. It means you can put a lot more weight, a lot more force into the machine. Now, there's also a pulley. Now, a single pulley like this just changes the direction in making machines. That's an important feature. But there's also what's called a compound pulley. Now, When you see pulleys, and I see it it wasn't until they invented modern pulleys made of steel with axles, absolute rubbish. You throw a rope over a tree stump, get a nice bit of wood that's been debarked, add some grease to it to reduce the friction. That gives you the same effect of a pulley. It just changes the direction. Now, compound pulleys, so these are blocks from ships, they are machines. Literally, they're machines. It's a compound pulley system. What you do is you have your rope, one piece of rope that's wrapped around and then comes back and then is wrapped around again. If you know how to properly rig rope, you can turn it into a magical anti-gravity device where it takes a fraction of the strength to lift a very heavy object. This is not theoretical physics. This is applied everywhere. It's literally how modern and ancient cranes get most of their power to lift heavy objects. See that contraption there on the edge? It's one piece of rope that's wrapped around and then goes back and is attached to the gearbox, and then the gearbox is attached to the motor. The motor on modern cranes cannot lift the weight that the cranes lift. Without the pulley system, without the gearing system, these cranes won't work, and this is ancient technology. All lifting technology is based on ancient shipping technology. Now, another example of a compound pulley. Again, you don't need low friction modern pulleys and axles and precision bearings. Again, another classical example with two bits of sticks and wraps. It's literally sticks and strings technology. This is only lost to the ancient Lost High Technologists who don't understand these basic things. So the small girl pulling on the rope pulls these two fellas together with ease, and the more times you wrap it around, the more powerful the pulley system becomes. Like when you first stumble across how a compound pulley system works, it's mind-boggling. It's like anti-gravity. It's like, why did I not learn this earlier? It should be learned in schools. Now, you can, with a single piece of rope, you can tie what's called a trucker's hitch. It's used in sailing as well. You can turn a single piece of rope into a crane, which makes you many, many times stronger. Just by knowing how to use the rope is very important. But so these basic machines that go back to antiquity, now maybe screws come later, but a screw is just an inclined plane. It's just a ramp, so just like a wedge. So the search for lost ancient high technology relies on being blind to never lost ancient knowledge. But then the constant comment I see oh lol, but wooden rollers would be crushed under the weight. These boxes weigh 70 tons. So wood's going to be crushed. Okay, now I hear that everywhere. Do you know where it comes from? Well, it comes from the Kemet School of Ancient Mysticism in conjunction with the Pons Institute of Physics, as presented in the Physics Laboratory with Yusuf. Okay, now this is not, I'm not cherry picking some old video. These are quotes that come from a recently re-uploaded video. Ancient engineering on the Giza Plateau with Uncharted X interviewing
straight rams or round rams. When we reach the level of having blocks weighing more than 70 tons, the theory of the rams will not fit. But it fit if we have only the blocks 1.5 tons, 2 tons, 3 tons. But then we will face the blocks in the... and he said the only way to push or drag the 70 tons block up to that level, we need a very solid concrete ramp with a very, very long measurement, and to have the smooth angle, and so we can drag or push that block smoothly to that level. So
on rollers from steel.
From steel.
Yes. To handle the weight, but a ramrod from mud brick and wood, that's going to sink.
Never happen. Yes.
But the slide shape can take. But let's put in mind, 70 tons on this level. Then when you change the angle going high from straight, it's not going to be much more than 70 tons. Yeah. We have lots and lots and lots to say about that subject. But he also suggested another thing, anti-gravity.
He also, for some time, This is a continuation of an interview that we held in Egypt a few years back with Yusuf Ayawan. If you're at all familiar with my channel, then Yusuf won't be a stranger to you. For those of you who don't know him, Yusuf is one of the premier guides in all of Egypt. He's a friend of mine. He's a real expert when it comes to a lot of the megalithic structures and the evidence for ancient high technology that can be found on sites and objects all throughout Egypt. Yusuf has spent his entire life studying the mysteries of Egypt. He's an accomplished stonemason, so he understands the practicalities of what it takes to work in a lot of the material. He does so himself. He's used both traditional methods and modern power tools and those types of things, so he really understands the machining marks and the objects that we're looking at. He's also an accomplished musician. He's the guy that I recommend to most people that want to visit Egypt and hire a tour guide that's going to give you both sides of the mysteries of Egypt, both the orthodox establishment view on it as well as the alternative views, including showing you all of the evidence for ancient high technology. I've learned...
these two knuckleheads. Now, this is what Lost Ancient Technology... We'll play the clip as well, but... on rollers from steel, so he's speaking about 70 tons, on rollers from steel to handle the weight, because wooden rollers would collapse under 70 tons. That's what he says. But a ramp road from mud, brick and wood, that's going to sink, because he even says that you need a ramp made of solid concrete, because that would collapse under the weight of 70 tons. But rollers from steel to handle the weight. Here's a wooden rollers not being crushed. Wooden wheels and axles not being crushed. Okay, but they have horses. Now, this is from America, where the quarry was many, many miles away from the final delivery site. Now you say, well, but Aswan quarry is 500 miles away. Yeah, but they had the quarry was right next to the river, less than a mile, and then the final delivery site was less than a mile from the river. So they only had to move them a couple miles. The river did all the work. These type of moves were done overland, and not just overland. Egypt is relatively flat. It's up once you're up the riverbank, it's pretty much level for all those ancient sites that they were moving to. So these were going up and down hills, and also they've got many animals because they're moving at speed. They have thin wheels over dirt roads as well, but then they're going up and downhill over a long distance. Here's another example. Now I'll show you other ones where you don't even need. This is an animal welfare thing. You could do with much less horses, but you want to make it easy on the animals to do this. Now, for instance, on this road here, you can see that the road starts to drop off. You can see hills in the background. A lot of these quarries are in unfortunate places, and they have to bring the stone down the hill, which means going up and down. Like there's not a dead straight road that just goes straight down from a mountainside. All mountain roads are going down, and then they go up, and then they switch back, and they have all these problems. So, again, easily you can do this. Now he says, but a ramp road of mud, brick and wood, well, that's going to sink. Well, 60-ton Abrams tanks, and we'll get to the weight. So these tanks are heavier than the heaviest object in the Serapeum. Now, there's no shortage. Everyone, tanks zipping across the desert sand, and a giant tank crossing over a dirt mound. These guys, this is a master mason, technical advisor, keeper of ancient wisdom, who is one of the main go-to guys for all the big ancient lost high technology tours. It's Brian Foster, Uncharted X. Now Johanna James says, oh, he's my teacher, and and she laughs at people and says it's science. Well, her science comes from these knuckleheads. Now, do you know where these expert Egyptologists and master masons got their information from in regards to what a ramp can support and what wood can support? Well, it comes from Dr. Mustafa Mahmoud, who had a long-running TV show investigating the paranormal. He was a medical doctor. He dropped out and became a journalist, and then became a famous TV presenter. Sort of paranormal caught on tape type of stuff.
ممكن يؤدي إلى أنواع من البلبلة لا نهاية لها.
So-called king chamber, 70 tons and more. So one of our famous doctors, he was a physician, but interested in mythologies and supernatural things. And he used to give like a TV program every week called Dr. Mustafa, and he actually talked about the Great Pyramid, and he said the only way to push or drag the 70 tons block up to that level, we need a very solid concrete ramp with a very, very long measurement, and to have the smooth angle, and so we can drag or push that block smoothly to that level.
On rollers from steel.
From steel.
Yes. To handle the weight, but a ramrod from mud brick and wood, that's gonna sink.
Happen.
But the slide shape can take. But let's put in mind, 70 tons on this level. Then when you change the angle going high from straight, it's not going to be much more than 70. We have lots and lots and lots to say about that subject. But he also suggested another thing, anti-gravity. He also
ممكن يؤدي إلى أنواع من البلبلة لا نهاية لها.
Up to the pyramid. Well, I'm pretty sure he's also the source of it as well. But these master masons, technical advisors, are pulling up what Dr. Mahmoud said back in the 70s or 80s, and using that he's their physics professor. A master stonemason, rubbish. Maybe he's good at carving his little trinkets there in the background, but he has no idea about it. This is just ridiculous. Now, this is where the information comes from. I'll play the clip. He even says it himself, all right? So I'm not saying he's an expert. He's not even an amateur, all right? Now, in regards to moving these, again, that 300-ton monolith being brought down a mountainside through narrow, twisting village roads on a sled using wooden rails and grease. So you see this image from ancient Egypt, the same thing. The Colossus statue on a sled. Now, here are some images from Babylon. I believe it would be Babylon era, but around about 700 BC from Nineveh. Or Assyrian, sorry, it would be Assyria. Top left corner, you can see the Lamassu, those winged bull with the head of a man, the stone being pulled out of a quarry. You can even see the workers on one side bringing out the rubble in baskets, and on the other side they're pulling this up the hill. Now, bottom right, they're now moving across level ground, and we get a good image, and that's the image I've focused on in the top right corner. Because what we see, again, they're moving on a sled, and again, wood dart. So Lebanese cedar, which is the favoured timber for the Egyptians and for the Babylonians and Assyrians, it has a crush strength of 6,090 pounds per square inch. That's 3 ton per square inch. Okay. Now, it's modulus of rupture and it's elastic, but the modulus, so it's how much can the wood bend. So crush strength is basically cut part of the trunk out, put it on, how much can it support, but the modulus also has to do with the bendability. So how much could you hang from the branch would be one way to look at it. And that's just twice as much. So ancient Egyptians, Assyrians, and even in more modern times, moving monoliths, how did they do it? They did it on sleds and with rails. And you can see rails being brought from the rear to the front, and now that's exactly the same method being displayed here. We can see underneath the sled, like a railway sleepers, and they're pulling them from the front, and they're putting them at the front, from the rear, to the front. On the Egyptian image, you can also see them moving a rail to the front. Could be a rail, it's not very clear. It could be a lever as well, or it could be both. But so just like with the Serapeum imagery from Nineveh, you've got a big lever and they're pulling down on a lever. And that's an important point. There's some dispute exactly what's happening here, because they're pulling down on the lever, so they're lifting up the back of it. But wet versus dry sand has been you see, just like those people on the 4-wheel drives, you always drive on the wet sand. If you're driving along the beach, you don't go on the dry sand because you get bogged. It's not there's been tests done on it, but it's, again, one of those things, well, obviously that's just what works. People have been doing that for a long time. All right, so is this fella here at the front of a sled, is he wetting the sand ahead of a move, or is he lubricating rails that we can't see that are underneath the sled? That would be the better option, but even moving it across wet sand would be working well as well, but you need a lot of water along there, so that's why I'd favour that they were moving rails and that those three fellas are bringing a rail from the back to the front, because just like when you go to the beach, it will usually be these pathways made of timber that sits on the sand. It distributes the weight. They don't sink down into there. And just like the Mussolini monolith, they're lubricating the rails with grease or fat or oil, some sort of lubricant, and it's sliding along. But it's also another important feature there is that what type of rail are they using on the Mussolini monolith, because here's the original photo of part of that relief from Nineveh. We zoom in and we can see that the rails that they're putting in front of the stone are not nice squared off bits of wood. They're using just basically cut off branches. That's an important feature, because if you use a perfectly squared off piece of like the wood you get from the hardware, it's squared off. There you have a big surface area. The lubricant is going to attach and basically form a suction cup with the sled that's being moved along, and you don't want that to happen, because then you have to break the seal, and you need to get that inertia and into momentum. So just like those in Mussolini's monolith, you can see that the rails are not squared off. They're lumpy and bendy, and so they don't have that surface area going on. Just like using logs that just cut off branches as well. So that's the difference. Now, there was an experiment. Mark Lerner had difficulty moving a 20-ton piece of stone, even broke the ropes and stuff. Well, he was using timber like that. What you got to do is look at what works and what the ancestors and our recent ancestors have done, learn from experience, and that's how it was done. So irregular rails are much better than squared off sort of hardware timber. So that also brings up this image. Why are they pulling down on the lever? If you wanted to drive the sled forward, you would put the lever underneath and be pushing up. Now, this will be propelling the sled forward in a way, but it's more than likely that they're lifting up the back to break the seal created by the lubricant on the rails that are being moved forward. But it also would move it, but it's not. You'd be much better putting in the lever and pushing up on it, not pulling down. So these are examples of never lost ancient technology, and it just works. Of course, you'll never ever see this on the Lost Ancient High Technologists, because they need to sell you on mystery and that it hasn't been done, and no, it can't be done, and wood would be crushed and stuff. Okay. So once you're in the confined space of a Serapeum, there's more than enough room, whether it's on sled and rails or on rollers and rails, to move massive heavy blocks. Another example would be what's called the shadoof, it's a lever with a counterweight. And if we go back to that image of him moving the stone, if we zoom, you can even see he's using a shadoof there. That is a crane. That's one of the well understood principles of lifting. It's a lever and it's counterweighted on one side. That's a very simple one that you can rig up in no time at all. I'll show you another example. Moving heavy stones. Moving heavy stones is child play if you have the right technique. And so he's using a lever and a counterweight and throwing these. He's not calling in a crane or a bulldozer or some sort of big forklift to do it. You can do these things with primitive ancient technology. So the loincloth wearing primitives, as described by Uncharted X and Bright Insight, they literally say that, the loincloth wearing primitives. They're always trying to dumb down our ancestors to sell their wares, but they were far more advanced in simple concepts and primitive understanding of basic tool making skills, far more advanced than the primitive Lost Ancient High Technologists who clearly haven't swung a hammer in their life or done a day's work, because if they did, 90% of a rubbish they say would not be said. They like to throw shade at other people, so I get comments, oh, but why are you so rude to them? Well, they always put shit on everyone else, you know. So what's good for the goose is good for the gander, and they're dumbing down society. They claim to do research and they claim to be scientific investigation. It's just rubbish. They're either entirely ignorant or they're scamming people. There's no, you know, being charitable. They're ignorant. Being more realistic based on their profit motive, they're actually doing this on purpose. So here we have some loincloth wearing primitives from ancient Egypt who made sailboats, where we can see their shadoof. Now we can see their knot tying technology. They made high quality hemp rope. This from the solar, but this was found next to the Great Pyramid. Now that's what you would use to rig a ship. Now here are some images. How to make a primitive winch, or making a flip-flop winch. So, you know, the loincloth wearing primitives. Now we have inbred hillbillies with sticks and ropes making very effective, very simple winching systems. Now here are some, you know, old hillbillies, loggers, you know, these, probably inbred as well, these inbred primitives. Well, what are they doing? Well, you can see, I've zoomed in at the top, where they just grabbed a stick and they tensioned the chain to hold these massive logs in. Primitive technology, because our ancestors were not stupid. They were smarter than us in the way, but if you did this now, people would be running off to the hardware or engineering supplies to get a ratchet or some sort of other device to tension this. This is how they were able to do it. But they're using chains. Well, you could replace the chain with rope. It's the same thing, like sort of... and even just a few horses to pull this on a sled as well. That's no small amount of weight on those logs there. So give our ancestors some credit. And here are some uneducated hippies with sticks and ropes, and they're using an A-frame to lift up the mast and put their mast up on their boat. So the loincloth wearing primitives who could make these boats also had to raise the mast, and they had to tension the ropes to support the mast and stop it from falling over. Loincloth wearing primitives had to have been using equivalent or exactly the same as these methods, because you can't just get people and apply that force with a guy just twisting and tensioning the ropes. You have to sail a ship and rig the sails. You have to be bringing in some form of mechanical advantage. You just can't get a 1,000-member crew to pull on the rope when you need the tension. Just like sailing boats now, they rely on winches to do there, because a person could not sail without mechanical advantage. Okay, now back to starting to bring in the block, but the heaviest boxes weigh 70,000 kilograms, and I'm only applying 9,000 kilograms here. Well, firstly, then let's go to the next question. So, how much do the boxes and lids really weigh? Lost Ancient High Technologists will tell you 100 tons, including the lid. Well, let's look, and so we have box 26, one of the smaller ones. We get an idea of height, so it's smaller than it's still pretty big, and we're looking at about 6 feet high, and we can use that to gauge for about 6.5 feet wide. I'm going to give a generous estimate and say it's 12 foot long. They don't tend to be 2-to-1 ratio, they tend to be a little bit less than that, but let's give a longer ratio. We can work out the external volume. Internal volume, we're looking at about 7.5 cubic meters of grey granite. How much does granite weigh? Between 2.5 to 2.8 tons per cubic meter. We'll use the higher number. So on the maximum side, that box would be 21 tons. Now, how much do the larger coffers weigh? This isn't the largest box, but it's one of the largest boxes with the thickest walls on there, and the thickness of the walls will greatly affect the weight. So is this 100 ton with the lid? External dimensions 4.8 by 2.17 by 2.3. Can work out the external volume. Now, I don't have a direct measurement of the thickness of the walls, but we can just do a little bit of detective work and get an approximate where it's about 1/2 the width of the hollow. So it's 2.2 meters wide, rounding up 55 centimeters. So, for instance, coffer 6 and these other ones, they have thinner walls. So that's again why I've chosen this one. This one almost certainly the heaviest. internal volume, subtract from external volume, 14 cubic meters. It's made of cyanite. How much is cyanite? 2.6 to 2.9. Let's use the larger number. And so that's 40.6 tons being generous. Easy enough. We've got measurements of the thickness of the lid. Cubic meters being very generous. I'm not accounting for the bevel for those corners. That's included in the weight. So the heaviest would be 65 ton, being quite generous. Now it's a big difference between 100 and 65, but even if they were 100 with this technique with levers, it would not still be an issue. But okay, let's say that the coffer we're bringing in is the 40 ton, the heaviest one. I'm still only applying 9,000 kilos with just these 6 guys, but just these 6 guys and 9,000 kilos would be enough. And so again, special presentation, the Kemet School of Mysticism with Pond's Institute, and in the physics laboratory with Mr. Yu.
And he said the only way to push or drag the 70 tons block up to that level, we need a very solid concrete ramp. It was a very, very long measurement, and to have the smooth angle, and so we can drag or push that block smoothly to that level. So
on rollers from steel.
From steel.
Yes. To handle the weight, but a ramrod from mud brick and wood, that's gonna sink.
Never happen. Yes.
But the slide shape can take. But let's put in mind, 70 tons on this level. Then when you change the angle going high from straight, it's not going to be much more than 70 tons. We have lots and lots and lots to say about that subject. But he also suggested another thing, anti-gravity. He also
ممكن يؤدي إلى أنواع من البلبلة لا نهاية لها.
Now again, he says it's 70 tons on this level, but when you change the angle going high from straight, it's going to be more than 70 tons. So what he's saying is that on level ground, you need 70 tons force to move a 70 ton block. But as you go up a ramp, you need more than 70 tons. Now, this is just like ignorant. This is stupid. No other way. Like how this is being presented by Uncharted X, and this guy is being presented by Uncharted X, and all the other channels. Brian Foster has the expert on technical issues, on ancient and modern technologies. These are experts like on their tour leaders. Now, you don't need a PhD level in physics. If you want to lift 70 ton straight up in the air at 90 degrees from horizontal, you need 70 tons plus a little bit more, a fraction more to do that. Now, moving on level ground, to move a 2-ton car, I can't lift a 2-ton car into the air, but I can easily push it across level ground. So an inclined plane, again, this is just what you can go on online, it's a very simple formula to work out the force. So 70 tons will never be 70 tons of force on an inclined plane. If you ever pushed a wheelbarrow up a ramp, or if you've ever moved anything up a ramp, like I don't know how this guy, again, he's an expert stonemason, the go-to expert for the Lost High Technology crowd. Is he lying and he knows the truth, or has he never ever worked a day in his life? Because he's no master stonemason would ever, anyone who's ever just worked on any trade or construction site for a week should have picked this up. This is the kind of stuff you learn as a child. Dragging something up a hill is a lot easier than trying to lift it and then walk up the hill. Again, this guy is no master mason. He's no keeper of secret wisdom. He doesn't even understand the basics of ramps. That you should sort of learn by accident with children. It's just okay. But then, but friction. Now, in a frictionless world, a mouse fart could move 1 billion tons across level ground, but we don't live in a frictionless world. But even then, so you're dragging something. So, for instance, that guy. Now, I don't think that fella could lift that weight that is dragging behind him. But you can, and again, anyone who's, if you can drag a sofa across. You can't lift it up, but you can drag it across. Even yeah, you just by dragging things. Have they never ever lived in have they never even go outside to play as children and sort of drag a big tree branch behind them or something? It's just remarkable. Now, just like now, our ancestors learnt how to overcome the problems of friction. If you mud will slide, wet stuff will tend to slide. Oil is slippery. Fat is slippery. But certain, just by living in nature, you're going to work out these things. The thing of you have to work out the coefficient of friction. This is just one of these, trying to make themselves to protect the narrative, and they dress it all up in these nice tidy words and make them seem like what they're talking about. But you can just dismiss it, because again, it's just it's verbiage, but in reality people have worked this out. And again, so many examples of it. Our ancestors worked this out. Unless you grew up in an apartment block and never went outside to play, you would have worked most of this stuff out as well. Sliding on the floor with your socks, or dragging something across carpet, even dragging something across a dirt road with all the little pebbles there as well. So again, why is this important? Because an incompetent teacher is worse than an incompetent surgeon, because a surgeon only cuts one person at a time. But this knucklehead, this fraud, Youssef, and all those who promote him are promoting ignorance, and they're dumbing people down, and they do zero. Their fact checking is what I like to hear. I'll include and make it. This is my scientific investigation. They wouldn't know reality or science if it hit them up the arse at 500 miles an hour. So it's hundreds of thousands, if not millions of people are being dumbed down so these few can line their pockets. It's snake oil. It's not just that they've got their belief system, but they're promoting it and dumbing people down with pseudoscience and just garbage, and in many cases outright lies and censorship. So can you move that block in there? Well, absolutely you can, because again, you can slide it. You're not with these levers at this point. It's on the ground. All you got to do is slide it. So just like a dining table, you can't lift it up, but you can slide it across. To move or slide something doesn't require the force of lifting it. Again, just so many. Work smart, not hard, and maybe just have a bit of experience in life. Demos on the power of levers, the theoretical lessons on levers. It's just everywhere. So this is settled science on what a lever is and how you can calculate the force that comes from there. And also you can get a hell of a lot more levers in that space. And also, let's see the little yellow triangle. Now, I mentioned earlier that the narrowness of that ramp to bring it in there works to your advantage, because now you can have a short pivot. But even then, you can still keep the short part of the lever from the fulcrum to the weight. Just tell a fella to bring a rock in and push it against the wall, and you use that as a fulcrum. I work on the assumption that the ancients were at least as problem-solving ability as what I've had and what I've seen, everyone that I've worked with, apart from a few people who are just like some people just don't have the but nearly everyone I've worked with has a problem-solving capacity, and I'm assuming that the ancients had this too. I know my parents and their siblings and the people that they grew up with working on the farm, they knew all this stuff. This was how they did things back in the old country without powerful machines and electronics. So just you can get this and move this in with ramps. Now you're coming down the ramp, so the gravity is assisting you as you're coming. So take advantage of gravity. Gravity is your friend if you know how to use it. So if you were to arrange, so I'm bringing on sled and rails, but if you were to arrange the rails like this, so you have one side, you put some ballast down and the rails are at an angle, then you have the ones which are level. As the stone comes down the rails, those angled rails are going to shunt the front sideways, and the stone will begin to turn. Gravity is pushing it down the ramp, and the rails are going to start turning and making this turn even easier. So this is overkill with levers. You'd probably, if you'd be having levers here, it'd probably be at the front of the stone, applying the brake, trying to control the stone coming in, not pushing it down. It's simple. Now, is there the stone will do the work for you. Gravity will help you as long as you arrange yourself correctly. There's plenty of room to get it in, and well, yeah. Now, this same method again, like with moving a monolith, they had to bring it down and then turn it in a sharp corner to bring it down through that viaduct. And you can also, the rails were not perfectly square. They were clever enough to use rails that are a little bit bendy, and so we wouldn't have that surface tension creating a suction. And they've also noticed that they got the rails tilted inwards. So they got like a rail on the outside and then tilting those, and that's going to keep this massive block running down the middle. If you just had them laying flat on the ground, it could start moving sideways. But you can aim this. They had to get it through tight, narrow streets. The roads coming down the mountain are not a nice straight concrete and asphalt road. It's an old mountain road with all the turns, passing through villages and all the tight little narrow turns that come into it. So here we see a 300-ton monolith on rails being slid and moved around the corners. It's going to take sharp turns all the way down the mountainside through these villages as well. Again, rails, stop, move the rails to the front, and again they're coming to, and they would have gone through all sorts of sharp corners coming down this mountainside through all these old villages down towards the port. Just like with a Serapeum, and we saw that earlier clip, coming down through that tight passageway, and again, just as they're doing here, lots of corners to go around, so there's room to move those Serapeum boxes in there, and those tight walls would actually be beneficial in a lot of ways because it gives you a place to put your lever. So this is an example. It was done in the past. So again, it's Lost Ancient Technologists seem to project their lack of experience and problem solving onto our ancestors, looking for fantastical solutions when there are simple solutions using the tools and the materials that were known to exist in the archaeological record. When they say it can't be done with what's in the archaeological record, they don't have the faintest idea what is, for number one, and they don't have the faintest idea how to use them. These guys are absolutely useless. They need roadside assistance to change a radio station for them. I don't know what I don't know. You could tell them to get a left-handed screwdriver and they'd probably take you seriously. So these stone pointers have been at this for years. They rehash the same material and they ask the same question over it. The mystery of mysteries, and how did the mysterious mystery get in the mystery box? Well, maybe, well, yeah, so this is how they look for solutions, and that's why they're hoping to get advanced high technology eye implants to find the solution to the problem, because they've blinded themselves and they're blinding their audience, and they're charging large sums of money for this as well. So you don't have to be a genius. There are examples of this being done. This is all settled science and being done in practice. So it's not a theoretical thing. So now we come to the wider. So we've got it through the door. Once you're through the door, everything from there is easy. There's a lot more rooms. That bottleneck there at the entrance, after that, easy peasy. Now, for instance, there we're at the door again, we see, just to mark it out, that's object lid number 1. And there we see the distance coffer number 4. Once that's in, straight shot. Now, what about this? Now, even notice where coffer 4 is, how it, it's like a triangle, it pants. So there's so much, so 3, 4 and 5 just virtually straight in, not a problem at all. And well, what about that corridor? Well, here's a screenshot. Sherif al-Kadi did a great tour, one shot, just walking through the Serapeum. And there we can see the people in the background. So let's do a scale. He's with one of the largest boxes. Got a guy standing next to it. We can use that as a scale. Put him there. make him taller than the tallest person there, so to be conservative and generous. And well, there's more than enough room to get these through. And again, that highlighted yellow part is a recent addition. There's been a lot of restoration work, archways and some walls built into the place. So the narrow part of a corridor, you got all the room in the world to, even if the lid was on it at the same time, and that wouldn't be the way to do it. You'd do it one at a time. But no, not a problem at all. The blue section, the corridor is even wider. Not an issue at all. And again, you can see bottom left how it is now, and older photo, a bit grainy, but you can see all of the restoration. You can drive a friggin' truck down there. There is no issue at all to get these inside. Just to compare it to some of the older drawings, they have a drawing on the right, exaggerates the size of these. And these are just tunnels in limestone. You go to any place in the world where they've got a mine or an old quarry or a series of catacombs, so that the cavernous mysterious, like how did they make these cavernous tunnels and niches? It's just friggin' limestone, and not high quality hard limestone either. It's all crumbly and grainy, you can see from the imagery as well. So that the caverns and the niches themselves, if you think that that's a mystery, your mind's going to be blown when you start looking into mines and catacombs and other things, including ancient ones, because this is very, very low on the scale of impressive when it comes to tunnel systems and that type of thing. But anyway, once you're through the front door, there's more than enough room to get all of these in. We just use that same method of angling the rollers, using levers just to turn it into the corner, just like you hook a large wardrobe through the door. The force applied by just a few guys with levers and the lubricant of a sled on rollers or rails, no, there's no issue at all. Now we have number 2. That's probably the largest box there, but it's in a very small niche. But that little square, so again the map gives a false impression. Now we here's a screen from Sherif, there he's standing out. What we have is a masonry wall there. Even at the front, that's masonry. That was added after. It's not the cavern. So we can take that out. So just like the front door, we see, how did they get it through that little door? Well, that door's modern. It's been added. So same with this masonry wall. So we can, again, fix the entrance and 2. And now what you have is you got room to hook it in there. It's like the Mussolini monolith, 300 ton. Now you can, levers, reds, sleds. Just not. That would be probably the most difficult. There is another one that would be a little bit tighter, but we'll look at. That's the same issue. There's a masonry wall there, which gives a false impression of the tightness to get it into a corner. Not a problem at all to get any of those in. There's more than enough room to get the coffers in and to twist them and turn them and bring them into their niches. But okay, I'm forgetting 2 of them, 26 and 27. They're in the top right. But before we go there, like right next to number 2 is a door, and behind that is what's called the lesser galleries. Again, that's a masonry modern door. That would be open. That would be a directly open archway. Here's a fuller map where we see the lesser galleries. And same thing, and it's just it's not it's a cut in limestone, a tunnel system. There are some other smaller sarcophagi. The Lost High Technologists don't really make any claims about advanced precision in this part because, well, they do, and we'll come to that. That comes to the making because there is a ridiculous claim made about this particular box. That one's inside the lesser gallery. Now it's an important one because again, now we have a masonry wall there, so the tight fit. Once you pull that, again, remember, if you take half a foot or a foot away from the corner, but that's a massive difference in being able to hook it around the side there. So if you take that masonry wall away, it'll be much easier. Now, this box is also important because we can see what's there underneath, and I would love to know what traces are there left underneath. Also on the top, you can see there's a handling boss, like one of the nubs, as they're called. All right, now 26 all of the other boxes are in their niche, basically sitting on the floor. 26 has a wood walkway that's built around it. We can't see what's directly under there. Would love to, to know. There are lots of solutions to this as well, and sand is one of them. But now I've highlighted 26 and 27. They're in the top right of the map. So 27 is a lid just inside the door. And there's another angle of it, and that's almost certainly the lid for box number 26, which is down this corridor. And it's a tight corridor, but again, once you've got something in a corridor, you just go straight. It's not so can you get it into that corner? Perhaps 26 was meant to go in the niche at the end of at the end of that corridor. So 26 is the box, 27 is the lid because they're similar size. Now we have a screenshot of. Now you can just see the yellow arrows is the width of the lid, which is the same as the width of the box compared to the opening. So there's no problem to get that in. Just again, as we brought in those others through the door, hook it, and even from there you can see if I was just take the far corner and start dragging that across, I'm going to be able to turn that into the corridor. I couldn't get a shot where I had a scaled person, but you can just see from here, there is no there's just no, if this was a piece of furniture and you saw that opening and someone goes, I can't get it in there, you go, you're an idiot. What's wrong with you? So I'm working on the highly biased assumption that our ancients knew how to use the basic tools they are known to have been using, and so it's no real issue to move these in. None at all. We have that lid there. Now it's worth mentioning because the sarcophagus in number 2, which probably the largest, 2.5 meters wide, it is lidless. But I don't know the exact dimensions of the lid next to the door. It's hard to tell, but that's probably reasonable enough to assume, but not for certain. So I don't see where it would be unexplainable to have moved any of these lids or coffers into their current locations. Just no. Just not an issue. There's more than enough room to pivot them, bring them in, turn them around the corners, assuming that our ancestors are not entirely incompetent and had no ability to do spatial mapping. Like if they could do hunting and all these other things, I'm sure they're able to do some basic calculations using their eyes. Once you're down into the ramp, it's level ground to the niches. Level ground along the corridor, I should say. Now, with rollers or a sled and levers, again, levers a bit, you don't need 1,000 oxen or 20,000 men dragging this. Just with the simple, most primitive of ancient tool, a lever, you can push them from behind. Also, at the front, you could use a primitive winch or sticks and strings, or wood and rope to make a compound pulley system. And the niches themselves, again, you just bring in a log, whack in a log on the niche, and you have an anchor point, so you can anchor these winches. So it's with primitive, simple technology that any sailor would had to have known about to operate his ship. You could move these with very small crew. It is just a fact. There's enough room to move them, and with a small crew, with primitive tools, you could move them and manipulate them around. So we could have brought them inside and we could have moved them to their niches, but it would be impossible for loincloth wearing primitives to have lowered them down into their niches. Well, I would say walk back out the front door. So here we see an example. We can, just to highlight it, in the yellow line I've got the floor level. You can even see the silhouette of a person in the background, but these have been lowered down into their niches. Now they've highly exaggerated. I've heard many cases where they make it sound like a bottomless pit, but it's basically human height, maybe up to 8 feet in some cases. But even if it was 30 feet, there's a very simple, elegant solution to this. So let's Photoshop that out just to make, so we've got the niche, it's empty. How do we get it in? Walk out the front door, and what we have is a sea of dry sand. You fill it up with sand. You could also use the rubble that's left over from emptying out the niche, because that would work as well. Place some rails, wooden rails down on the sand. But again, you can see it just like with a tank or like this bulldozer here. They can go over wet sand and bog because it distributes the weight. So wooden planks will distribute the weight. Just like you brought it in, you lever it in from behind. The wooden planks or rails will just go straight in as if it was on top of a limestone. Because again, they distribute the weight. It's not going to sink in there. This is, it's I don't know where these notions come from. So you get it in there. Now, there's always a what about. So at that last point, you wouldn't be able to lever them in, because if you try to use a lever against the rail, it's going to dig into the sand and push it back. Well, you just bring in a rock or a piece of wood, put it against the back of a wall, and you have a pivot, a fulcrum to apply that. No issue at all. Basic problem solving skills. Okay, now the timber is trapped underneath. Well, no, it's not, because if your car's bogged, you dig underneath one of the tyres and you whack in a piece of wood or one of these more modern plastic rails. The sand is there to be dug out. You dig out one tyre at a time and fill it in. So if you can dig under to place a beam, a plank or whatever underneath a tyre, you can dig underneath to remove that with exactly the same principle. What goes in can come out. So as an example, okay, we have this, we brought him in, it's sitting on top of the sand. What do? We dig out a little bit of sand in the middle, we pull away those rollers or rails, either way. Dig out at the front, it's going to tip forward, which means we can pull the ones out from behind. Dig a little bit more, it's going to tip the other way. Pull the ones out the front, and now we've got our stone sitting on sand. And even the stone, you can see giant glacial erratics, those huge boulders deposited by the glaciers sitting on soil, thousands and thousands of tons sitting on soil. That it's not gonna sink. All right, but this is seesaw and beach pail and spade level technology. Another example would be Wally Wallington does the same thing to get he lifts up his giant stone, the upright, for instance, replica of Stonehenge. Then he fills a sand pit, lowers a corner onto the sand pit, and then he's washing it out, but you could just as easily just bucket it out.
Whoop. The first goal is getting this block 3 feet off the ground.
In order to move it up to this point, I just rock the block back and forth, adding weight to that end, and that opens a gap on this side, and just slide a board in. Then I add the weight to that end, there she goes, and slide a board in on this end.
This shoring box acts like a jack, slowly raising the block. It's 3 feet off the ground, but tomorrow is the big experiment, standing it up. The grandkids have taken the day off school, and the cameras are rolling.
Hey, you guys watch Papa, he's going to do something wild.
They're here to watch Grandad lift a block the weight of 2 bulldozers.
It's ready.
Here's how it's supposed to work.
The first thing I'm going to do here is release this temporary shoring I have set, and come over here, release some of my counterweights, and that's going to put the entire weight of the block on this rope. So then I'm going to release the rope, come back in, and the rope's going to be my brake. I'm going to guide it into the pit. The easiest way I can explain this is this is just a big teeter-totter, and I got the big kid on that end, and he's going to go down, this end's going up.
He believes in his technique, but he's had some setbacks in the past.
One day I got thrown over top of a block, and a couple times I had the blocks roll off the top and almost land on my feet. One time I knocked myself out cold on the concrete. And so it's been challenging. Okay. Are you ready? Yes! All right. Now just start spraying the sand. The sand will wash out and the block will start coming down.
Once the sand is washed from the pit, the block's own weight slowly stands it up.
Okay, finally, she's between the lines, guys. Looks good.
He did it.
Thank you, guys.
Raised a massive block.
And as the sand goes down, the upright goes up. Another example would be this experiment with raising an obelisk. Again, just like Wally, this is using seesaw technology in sand. You fill in a big pit of sand, dragged a...
6,000 miles from Egypt at a granite quarry in Massachusetts, American sculptor Rick Brown tries a different method.
Okay, let's point this thing to the sky.
His design relies on sand, a material the Egyptians had in abundance. The main force at work is gravity. As the sand is cleared away, the obelisk sinks under its own weight.
It's big and it's massive, but it's using very simple forces, simply the force of flowing sand.
To ensure that it drops down precisely into the turning groove, the obelisk is guided by steps built into the back wall.
The obelisk halfway over, as you empty out the sand, it seesaws and it starts tilting up. Very easy to do, but you have a loincloth wearing primitives. Just because you wear a loincloth doesn't make you ignorant primitive. Being an ignorant primitive makes you that. So we've got it in, no drama along the way. Now it's on top of a wood. We can just dig that wood out. It's not an issue at all. Start bucketing out the sand. We bring it to the bottom. Now there'll be a thin layer of sand there at the bottom. Well, throw in some water and slosh it around, and again it's going to, grain by grain, you just keep sloshing it around, it's going to wash out that sand from underneath. But a more elegant solution would be to place a layer of salt at the bottom, and it will dissolve away. And so now you've dropped your giant, without having to have a rope underneath, without having to lever it or winch it up. You can use gravity to your advantage again to do this. So, and now of course, yes, the lids are essentially at ground, the level of the corridor. I mean, you just build a simple wooden rail and you push them and slide them across, or you could fill one half with rocks and then sand, and then put a layer of wood down so not to scratch the lid. This, problem solving, people. Problem solving. It's not a hard thing. So you've been listening to people who don't even properly analyze the problem, let alone look for a solution. It's part of the grift. Now, another thing worth noting is that, now here's some photos where you can see that all of these niches are large and arch-shaped. However, we have a collection of niches which are not like that. So we look down here, 2, 3, 4, and 5. And they're worth looking at as well. Now, number 3, what do you notice on the end of the lid? Just like the lid at number 1, which has the handling bosses on there, we can see that this box, and the lid, has had handling bosses there which have been partially removed, but not completely, so they still leave a trace there. Handling bosses, lifting points, standard ancient technique. Also a levering point as well. So again, if you want to just inch the box a little bit forward, once it's there, you want the lid right on nicely, well, that's a good lever point to do it. Now number 4, now doesn't come quite across maybe with the photos, but number 3, you can see that the niche is a little bit not very nice. None of them are Mickey Mouse, but this one's still a little bit rough and squarish. But if we come to 4, okay, now you can see that the niche is done. There's been a little bit more detail done to the niche to make it more arched. It's still narrow compared to the bulk of the others, but the work's been carried on a little bit further. But when we come to niche 5, we can see it's very, very rough. Look up there at the roof behind there. But this is good because I don't think they've this one. They didn't go to the effort of finishing it off, because this is not the only one. 2 had the same thing, but we can just focus on 5 for the moment. And what we have is traces of how the work was done. Now, here's another handling boss there on the edge for either a lever or a sling to help with the moving. But here's another box doesn't have, but what it has is holes drilled in there, and you can see that the holes are drilled throughout. It's not just a shallow; it goes all the way through. Perfect place to put in a nice big piece of red cedar, which has massive prop, but also just feed your rope through that. All right, so any explanation is reasonable apart from the ancients having mastered the basic skills required to build sailboats. Because, what does he say? Dr. Mahmoud, he also said, this was a guy who said, ramps sort of and don't work, and 70 tons will collapse on wood. But he talked about anti-gravity. Well, they've always got, looking for anti-gravity everywhere. No simple machines. No basic, our ancestors were all dumb, but then there was this master race back in the distance who had magical abilities. Didn't leave a trace, of course, but anyway, so you can see number 5, bottom right corner, I've zoomed in, you can see that, and the footage will show that. I'll put the full link in from Sherif tour, but there are holes drilled on the side there, feed the rope through, creates a lifting point, and you can also see in the roof that they got these little nooks, little holes in the roof, which is a perfect place to insert logs. And I've got just a generic picture, I wouldn't use bark, I would take the bark off, polish it up, put a little bit of grease on there. And so the loincloth primitives who built and rigged sailing ships, which is the exact technology you need that makes modern cranes, and they had excellent rope. All sailing ships, even like ancient cranes depicted by the Romans in high detail depictions, they knew this is how it works back then, and all modern cranes are still based on exactly this principle of ancient ship rigging. Simple things like a trucker's hitch. It's not just a knot to secure things. You can use that as a force multiplier, give you mechanical advantage. You can lift many, many times. You just loop it again. So if you take a trucker's hitch and attach it to a primitive winch, you have a very powerful winch, or a crane. Sorry, not a crane, but a crane. And that's a primitive winch attached to a compound pulley like a trucker's hitch is how cranes work still now. Make a simple D shackle, so instead of going rope against rope, you overcome the friction and the pinching of a rope. So these are very simple problem solving abilities to come across. So those in the comments who pointed that out, it's again got to address it. It's like, where are your problem solving skills? You're always looking for problems, never looking for solutions. Very simple solution. So again, the loincloth wearing primitives of dynastic Egypt, they ruled over a massive territory. They had a sophisticated bureaucracy. They were engaged in international trade and shipping. They were able to assemble armies and go on campaign. They are not the bumbling imbeciles that the Lost Ancient High Technologists need to portray them as, because that's the only way they can make their argument strong, is to create straw men. They're all dumb and they couldn't use levers, and they were wearing loincloths and just banging stones out in there. They survived in a world where there were savage predatory animals and aggressive tribes that were willing to fight them. They survived that. Lost High Technologists would be wasted in 5 minutes. They couldn't survive. All right, so what you have, and also bent pyramid, you can see the red cedar I mentioned earlier. Now, Lebanese cedar is not, it is a great timber, one of the better ones, but it's not like a Superman of timbers. Even other timbers could support these weights as well. I'm just using that as an example because that's what we see ships that they made, and also found in the pyramids, from bent pyramid Maidum. Trucker's hitch connected to a winch. Again, you have no shortage of points to anchor this down. You can make a crane, a hoist crane such as this. So you don't need a big, long, like a construction crane. They're all different types of cranes. A hoist crane such as this, where it's it's right there. You could just take that blue frame and the ropes hanging from it and attach it over there to the logs, attach a winch to it, and you have a powerful crane. Very simple, primitive technology. Or, this is more fun, as Graham Hancock put it, he poo-pooed mechanical advantage, and then, you know, maybe they sung to the state. There's some vague text somewhere where someone sung to the, and that's how they lifted them. It's anti-gravity, lost high technology. Solutions, proven ancient technology that still exists with us today, and problem, lost ancient high technology, always looking for problems, blind to solutions. So is it impossible to get the coffers and the lids inside the Serapeum of Saqqara? False. No, it is. It's not only possible, it's entirely feasible, as the word goes, and so that's incorrect. And is it impossible for loincloth wearing dynastic Egyptian primitives to have moved these coffers and lids with their primitive tools? That's also false. Where is the mystery here? They need to have the mystery, but I'll guarantee you, I'll still keep selling it, because it's a business. That's what it is. It's not about truth seeking or protecting humanity's future and the past and retelling, you know, and restoring the true history. It's a business, and they can't show you this because it's a house of cards. Once one part goes, and the whole house collapses. So next will be, is it impossible for the loincloth wearing primitives of dynastic Egypt to have made these lids and coffers with their available tools and materials? Well, they say it is. We'll show you certainly it isn't. And the lids and the coffers are made to impossible levels of precision. It's precision, symmetry, precision. And it's beyond what can be achieved with primitive hand tools. That's the claim. And again, I already did a video on that one in the past, but I'll do a more in-depth one. And, it's going to go the same way as those who said it can't be moved. And so with that, that's it. Alrighty, yeah. The Serapeum and this lost high technology stuff, just like with the precision stone vases and all these other claims, are absurd, and they're built on, you wouldn't even call it pseudoscience. It's just cherry picking of falsehoods, and without the falsehoods, the whole thing falls down. So more to come. This is part one. Again, it takes a lot. They can make a claim like this in one sentence. It's impossible to move these boxes. There's not enough room. And if you say no, it's, well, where's the evidence? You know, they're exempt. They have no responsibility to provide any evidence. They just make a claim, and they poo-poo everyone else, and then they get all upset and like, oh, you know, my fees. How dare you be mean to me? Well, you get what you give. And in this case, and this is again another ridiculous claim, and it's dumbing down society. It's robbing you of your birthright to, you know, instead of educating you on what can be done with primitive tools, they're dumbing you down and dumbing children down, which is just shameful. It's disgusting that they would do this to young people and take their birthright away, and also steal other people's, our ancestors' achievements to sell money. It's shameless. You're con men and they're frauds. With that, have a good one.